Far beyond Earth, orbiting the giant planet Jupiter, lies one of the most fascinating worlds in our solar system. This icy moon is called Europa. At first glance, Europa appears to be a frozen and lifeless place. Its surface is covered by a thick shell of ice, crisscrossed by long fractures and ridges that stretch across the entire moon. Temperatures on Europa's surface can fall to minus 160 degrees Celsius, making it far colder than the harshest environments on Earth. For a long time, scientists assumed Europa was nothing more than a frozen desert in space. But over the past several decades, spacecraft observations have revealed something extraordinary beneath that icy surface. Hidden below Europa's frozen crust may lie a vast global ocean of liquid water. This ocean is not small. In fact, scientists believe Europa's ocean may contain more water than all the oceans on Earth combined. The discovery of this hidden ocean transformed Europa into one of the most promising places in the solar system to search for extraterrestrial life. The idea may seem surprising at first. After all, Europa is extremely far from the sun, receiving only a tiny fraction of the sunlight that warms Earth. Without sunlight, how could liquid water possibly exist? The answer lies in the powerful gravity of Jupiter. Europa experiences intense gravitational forces as it orbits the giant planet. Jupiter's enormous mass constantly pulls on Europa, stretching and squeezing the moon during its orbit. This process is known as tidal heating. The repeated flexing of Europa's interior generates heat deep beneath the surface. That heat is believed to keep the subsurface ocean from freezing solid. Evidence for this hidden ocean comes from multiple sources. Images taken by spacecraft show that Europa's icy surface appears relatively young and constantly reshaped. Large areas of cracked ice look as if they have been broken apart and then refrozen. Some regions even resemble the shifting sea ice seen in Earth's polar oceans. These features suggest that the ice shell may be floating on top of a liquid ocean beneath. Additional clues come from measurements of Europa's magnetic field. Data from the Galileo spacecraft indicated that a conductive layer exists below the surface, consistent with a salty ocean of liquid water. If Europa truly has a deep ocean beneath its icy crust, the next question becomes even more exciting. Could life exist there? On Earth, life exists almost everywhere water is found, even in extreme environments. Deep in the oceans, far from sunlight, entire ecosystems thrive around hydrothermal vents on the seafloor. These ecosystems do not rely on sunlight for energy. Instead, they depend on chemical reactions between hot water and minerals rising from deep inside the Earth. Some scientists believe similar hydrothermal vents could exist on the seafloor of Europa's ocean. If hydrothermal vents do exist on Europa's ocean floor, they could provide the energy and nutrients necessary to support microbial life. In Earth's oceans, hydrothermal vents host communities of strange and fascinating organisms, including giant tube worms, shrimp, and bacteria that survive entirely without sunlight. These organisms rely on a process called chemosynthesis, where chemical energy replaces sunlight as the source of life's energy. If a similar environment exists within Europa's hidden ocean, it could provide the right conditions for life to emerge. The challenge for scientists is that Europa's ocean lies beneath a thick shell of ice that may be tens of kilometers deep. Reaching this ocean directly would require drilling through the ice, something that current technology is only beginning to explore. However, scientists are developing new missions designed to study Europa in greater detail. One of the most important upcoming missions is NASA's Europa Clipper spacecraft. This mission will perform dozens of close flybys of Europa while orbiting Jupiter. Using powerful instruments, the spacecraft will analyze the moon's surface, measure the thickness of the ice shell, and search for signs that material from the ocean may occasionally reach the surface. In some regions of Europa, scientists suspect that plumes of water vapor may erupt through cracks in the ice, shooting material from the subsurface ocean into space. If these plumes exist, spacecraft would potentially fly through them and analyze their chemical composition, detecting organic molecules or other chemical signatures in these plumes will provide important clues about the potential habitability of Europa's ocean. Even if life itself is not directly detected, discovering the chemical ingredients necessary for life will be an extraordinary step forward in our understanding of the universe. Europa represents one example of a broader class of worlds known as ocean worlds. These are planetary bodies that contain large amounts of liquid water beneath their surfaces. Other ocean worlds in our solar system include Enceladus, a moon of Saturn, and possibly even distant dwarf planets, such as Pluto. The discovery of these worlds has dramatically changed our understanding of where life might exist in the universe. In the past, scientists believed that planets needed to be located in the so-called habitable zone around a star, where temperatures allow liquid water to exist on the surface. But ocean worlds like Europa demonstrate that liquid water can exist even far from the warmth of a star, as long as internal energy sources are present. This realization greatly expands the number of potential places where life could exist. Instead of searching only for Earth-like planets, scientists now consider a much wider range of environments where life might emerge. Europa may one day become one of the most important destinations in the search for extraterrestrial life. Beneath its frozen surface may lie an alien ocean that has remained hidden for billions of years. If life has arisen there, even in the form of simple microbes, it would prove that life can emerge in more than one place in our solar system. Such a discovery would forever change humanity's understanding of our place in the universe. Even if Europa's ocean turns out to be lifeless, studying it will still teach us a great deal about the chemistry and physics of icy worlds. Either way, Europa remains one of the most intriguing and mysterious destinations waiting to be explored in the vast ocean of space.